Hi everyone, this lesson is for Algebra 2 Honors students. This is a quadratics review for your quiz 3 that you're going to be taking. So let's get started. Let's see. All right, we're going to warm up with a derivation of the quadratic formula. So basically, the way we're going to do this is we are going to complete the square. And we are given a quadratic equation in standard form, and our job is to somehow make this work out to get to the quadratic formula. So let's try this and see what we do. And using the quadratic formula always is getting you the intercepts. So the purpose for that would be starting off to set this equal to 0. So we have ax squared, we have plus bx, and then plus c equals 0. I'm going to start off moving my c over to the other side. So we have negative c is equal to ax squared plus bx. Now remember, when we are completing the square, our x squared term does need to be a 1, positive 1. No values next to that. So we are going to factor out that a. So we have negative c equals a times the quantity, x squared. When I take it out of the b, it's going to be b over a. X, and then just remember that you could multiply that back in to make sure you get the term that you factored it out always. So to figure out what I'm going to be adding to both sides when I do complete the square, remember we take that b over a term, right? We take half of that term, half of the b term, which happens to be b over a, and then you square it. So we have b over 2a quantity squared, which is basically b squared over 4a squared. Okay. Now remember, whatever you add to the one side, you do need to add to the other side. But if you factored out something, right, like this a, we need to put that back in. So that'll be a times b squared over 4a squared. And what happens is one of my a's cancels out. So I'm left with here b squared over 4a. So now what we're going to do is we are going to factor this. So we have a here, and then we have x plus, it's basically the square root of this first term, and it's the square root of this last term. So the square root of that last term is just b over 2a, and remember that's quantity squared. And then on the left-hand side, I have two terms. I'm just going to combine those two terms, meaning I'm going to multiply this c value by 4a over 4a so that I have everything over one value. So I've got, looks like I'm going to have b squared minus 4ac, that sounds familiar, all over 4a, and it equals this right here, which is, let me just move this over here. So there we go. And so now what we're doing is we're going to get rid of this a. Because ultimately, I'm going to square root both sides to isolate the x. So in order to do that, I need to divide by a. So in dividing by a, right, multiplying by 1 over a, these are going to cancel. On the right-hand side, I get x plus b over 2a on this side here, squared. And on the left side, I'm going to get b squared minus 4ac all over 4a squared. And so now I'm going to square root both sides to get rid of this square here. And remember, when I square root something, that's a half power. That's why you're multiplying 2 times a half to get rid of that 2. So we're going to square root both sides. And remember, when you do that, that square root on that side, when you're solving for x, is going to be plus or minus. Don't forget that. So on the right, we have x plus b over 2a. On the left, we're going to split those up. We're going to get plus or minus here. We're going to get this top part, which is b squared minus 4ac. And on the bottom part, we're going to get 2a. And then I'm going to move this b over 2a to the other side. It's positive here, so when I move it to the other side, it'll be a negative b over 2a plus or minus this stuff, which is the square root of b squared minus 4ac all over 2a. And that equals x. And then my last step, because they both have the same denominator, is I'm actually just going to combine them. And I get x equals negative b plus or minus the square root of b squared minus 4ac. I didn't give myself enough room. Darn it. Okay, so b squared, negative b plus or minus b squared minus 4ac all over 2a is equal to x. Right on. How's that? Pretty cool, huh? Okay. Second part of today, we are actually doing some presentations, so we'll do that in class. Make sure you're ready. So we're going to start off doing our review for our quiz, which is the linear inequalities. By the way, the derivation is not on your quiz. Given the following requirements, write inequalities expressing each of these requirements. Plot the graph of the solution to the system. So we have, the first one says the sum of x and y. So add those. X plus y is at most. So it can't be more than. So it's at most, right? 10. So we're going to do that. Could be equal to 10, but it's at most. Y is less than twice x. So y is less than twice x. And then the last one is y is at least. So it could be more. At least 2 more than 1/3 of x. So 2 more than 1/3 of x. So, and it's y is at least. So that means that it's either equal to or greater than. And so we have those values. And that's it for that. I just wrote these in different order. Yeah, I felt like the other way better, where you just make sure that you put the x value first, and that's a better way to do that. And then lastly, I do expect you to graph this, and graphing this, so for the first one, I would solve for y. So you have y is less than or equal to negative x plus 10. And so we're going to start up 10, and then it's a slope down 1 over 1. So, and it is solid. It said it's less than, so I am shading below, right? So you shade below. This one says y is less than 2x. So that one starts at 0, goes up 2 over 1. And this one, though, this one actually is a dotted line, and it's less than, so that shades down. So far, the only shaded down part is this stuff in here. This one, we start at 2. So we're going to start at 2, about there. And it goes up 1 over 3. So that's going to look like that. So basically, it's more wider like that. So and it's greater than or equal to. So it looks like it's this shaded region here. I would suggest that and encourage you to do this on your calculator. Absolutely. But at the same time, I know Desmos is, something that you can do right now. You have this right here. We plotted the graph of the solution. We wrote the inequalities. I just want to make sure that you can be able to write these equations yourself and know what those points of intersection are. And remember, sometimes it's necessary to set the two equations equal to each other to see what that intersection point is. Okay, cool. This one right here, linear programming, an auditorium contains 1,000 seats. So for an upcoming event, tickets will be priced at $9 for some seats and $6 for others. At least 400 tickets are to be priced at $6, and a total sales of at least $5,000 is desired. Find a system of inequalities that describes all the different possibilities for pricing the two types of tickets. Definitely, I would turn the video off for just a minute and write down everything that you think you know about this problem, and then check your answer, because your job is to write a system of inequalities. I'm not asking you to graph it, but I am asking you to write it out. Okay, so take a moment, pause the screen, and then I'm guessing that you're back. So I'm going to bring up what I have here and what I did. And so just making sure that you check your work with the linear programming. It says the auditorium contains 1,000 seats, and you've got different tickets. You've got tickets that are priced, let me fix that, priced at $9 for some seats and $6 for the other. But there are two types of seats. right? You've got a higher value and a lower value. So those two values, you can say let x equal the higher value, let y equal the lower value, and then you have x plus y is greater than or equal to 1,000. At least 400 tickets are to be priced at $6. So that's where this one right here, where you have x is greater than, because at least, anytime it says at least, it has to be greater than or equal to. Now this one right here talks about the money, and that's, you've got $9 for some seats, those are your x, and you've got, or you flipped them around like I did in this case, you've got $9 and you've got $6. So you've got 5,000 desired altogether that you want to spend. And then lastly, it says, well, you want to make more than no money. So these are the system of equalities. These are types of tickets. These are your possibilities. You would graph this if they asked you to graph this, which they will ask you to graph this on the quiz as a separate problem, and you're going to be turning in that work for this problem. So make sure you can graph, yes, you can use Desmos. I would like to see you practice on your graphing calculator, but so for this one right here, I would ask that you do two different things. Find the minimum value and also the maximum value. I'm giving you C equals 5x plus y on the region, so that's my profit or cost margin. I want the minimum and the maximum. So what I would do is I would start graphing each one of these problems. So for example, I've got x is greater than or equal to 0. So x is vertical, so that's this one that's going to go straight down like this and go through x, pierces through the x, greater than or equal to, so that's, we're talking about shading everything over here on the right. Y is greater than or equal to 0. For this one, we're talking about this line going across at 0, and we're talking about shading everything above that, right? But because we're looking for, of course, that intersection point, now the values below and above are not accurate, and so that's out of the question. These two are done. This one here, I would solve for y, so I would say 2y is greater than or equal to negative x plus 300. Divide by 2, I get y is greater than or equal to negative 1/2 x plus 150. So, wow, the 150 is way up there. So that, let's just say, I don't know, let's say it's about here. Let me use this picture, this color. And then my slope is down 1 over 2. So at some point, this is going to go down like this. And it says that it's greater than, so then everything above that is shaded. So that means anything below is not. Okay, and then this question here, that's done. X is greater than, or actually, let me rewrite that, is y. Y is less than or equal to x. And then remember, that's a plus 0. So let's put that here, and that's just up 1 over 1. That's a line that goes straight across like that. And it says less than, so now we're talking about below like this, right? And so that means that anything above that is out. And then lastly, I am going to solve for y on this problem. So 2y is less than or equal to negative x plus 900. Divide by 2, I get y is less than or equal to negative 1/2 x plus 450. Way up there. Now, for this, actually, this is way up here at 450. Remember, this was 150. These do have the same slopes, though. I noticed that this slope here for this green, for this equation here is the same as this one. So they are going to be parallel. So I'm going to just make sure that it's parallel to this one that started at 150. So here we go. There it is. And then that one is also less than. So we're talking about this area in here, okay? So now what you need to do is you need to decide, okay, where's my maximum and minimum values? Now what you need to do here is you're actually going to have to figure out where these points are right here in the corners, right? You need to come up with those points, and then you're going to plug those in. And the way you come up with these points is that you set these equations equal to each other. So for this one here, the 150, that's this equation here, and this line here, which is my y is equal to x, or y is less than or equal to x. So if they're both equal to y, I would set those equal to each other, and I would say, what would I say? I would say x is equal to negative 1/2 x plus 150, and I'm going to move this over. Let's see here, 150. And I'm going to move this back over to the left. And so now that's plus 1/2. So 1.5. That's 3/2 x equals 150. I'm going to multiply by the reciprocal, which is 2/3, right? These are going to cancel. 5, that goes in there. So what I would do, use your calculator if you need it. I know this is what? X is equal to... 3 goes in there 50 times. 50 times 2 is 100. So when x is 100, here at 100, where am I here? So I need this point. So I've got 100, comma, and I got to plug it into one of these two. This looks like if I plug it into this equation, it's 100, 100. Okay, so there's 1 point. To find the next point, I do the same thing, but with the 451. So... definitely running out of room, so I'm going to erase this. Shouldn't have erased that, and I lost my equation. 2y less than or equal to negative x plus 900, y less than or equal to negative 1/2 x plus 450. Now that negative 1/2 x plus 450 is going to get set equal to the y equals x, because that's this one and this one together. We're trying to find this intersection point up there. And so that's going to be equal to x. Again, I'm going to add the 1/2, and so then I get 3/2, 1.5, which is 3/2 x, equals 450. I'm going to multiply by the reciprocal, which is 2/3 on both sides, right? Get rid of that. That's gone. I get x equals. And then 450, right, divided by 3 is 150 times 2, right? 300. And so we got x is equal to 300. And so for this one, when I plug this in, right, 300, 300, again, let's see what we get for that. 300 and then 300. So far our points are, we've got a 100, 100. We've got a 300, 300. And now we need this last point, which it looks like it's down here because these are parallel, right? Those are actually going to just keep going. And I'm going to look at this point, which this is y equals 0, right? Yeah. No. Yeah. Yes. Y equals 0. And then the other one, the red one, is the 150. So where is that? That's this one. So we've got negative 1/2 x plus 150 is equal to 0. So I'm going to subtract 150 from both sides, right? So I'm going to get down here, negative 1/2 x equals negative 150. I'm going to multiply by negative 2 over 1, multiply by negative 2 over 1, and I get x is equal to 300. And so that value was 300, comma 0. Okay, so now, finally, we've got all of our points, and now we've got to actually find the max point and the minimum point, okay? So we need to plug these values in to our equation. And so our equation is right here that we were given. So we have c is equal to, and you got to plug in all 3 points. So we've got c is equal to 5 times 100 plus 100. So that's 500 plus 100, which is 600. So this one yielded 600. C equals 5 times 300 plus 300. And that's 1,500 plus 300, which is 1,800. And then the other one is 5 times 300. Let me erase this. 5 times 300. And then plus 0, which is 1,500. So the question says, find the minimum and the maximum. Well, the minimum is going to be here at 100, 100, because that's the lowest value, right? Minimum. and my maximum is going to be at 1800 when that is 300, 300. So this is my max. So this is the max right here, value, and this value here is the minimum, even though you've got to be careful, right? Even though that value looks like it's the lowest value, it doesn't yield the smallest output. So this is just my graph. I'm going to overlay it up here so that you can just see it. Maybe I'm going to do that. Give me a second. There we go. And so I'm going to overlay this so that you can actually see this a little bit better, where you've got the 100, you've got the 100, 100, 300, 300, 300, 0, and these are your values for that problem. Know that, okay? So this one is asking me to complete the square to find the vertex for the equation below. So we're going to complete the square for this problem. I'm going to change this to y. I like y better. And I'm going to move that 5 over to the other side also. So in doing that, I get y plus 5 equals 3x squared minus 6x. But remember, completing the square, you have to factor out that 3. So we get y plus 5 equals 3 times the quantity, x squared minus 2x, right? 3 times 2 is 6. There we go. So half of negative 2. So we can take that negative 2. We take half of that and then square it. So that's negative 1. Negative 1 squared is 1. So plus 1 here. And then I'm going to go plus 1 here. So I get y plus 6 equals 3 times the quantity, x minus 1 squared. And then, did I miss something? Yes, I did. I didn't add this 3 times 1. So make sure you do that. So I do, oh, I tried to do that. I did it incorrectly. Let me fix that. Yeah, be careful because you are adding 1 to both sides, but it's actually 3 times 1. So there we go. All good in the hood here. So y plus 8 equals 3 times x minus 1 quantity squared. Now we're set. Vertex form would be y equals 3 times x minus 1 quantity squared minus 8. This is vertex form. This gives us a vertex at 1, negative 8. Okay, so far we have a vertex at 1, negative 8 right here. I'm going to put a V there. 1, negative 8. Tell me everything you know about this. I mean, everything you know. My y-intercept is going to be at negative 5, so that'll be here. I want my x-intercepts, and I know that this is going to be a minimum because it's a positive graph. I do want my discriminant, which is b squared minus 4ac, b squared, so that's going to be negative 6 squared, minus 4 times a is 3, times c, which is negative 5. So what is that? 60 plus negative times negative is positive, 36. So that's what, 96? Okay. So we did the y-intercept. That's at parentheses 0, negative 5. We haven't done our x-intercepts yet. Domain, I haven't done yet, but we know that's going to go like this. We know our graph is going to look like this. So we know that actually the domain will be negative infinity to infinity. I know my range is my lowest point, which will be negative 8, up to infinity, parenthesis. So we know all that. We know the discriminant, what is 96? What does that tell me? It tells me I have 2 real, but not rational. They're irrational. And they're irrational x-intercepts because when I take the square root of 96, right, you're not going to get a real, you're not going to get a rational number. If you go second square root 96, it gives you like 9.8, something like that, which is not, it's not a rational number. A rational number would be when I took the square root, I got a whole number, right? Okay. So lastly, what do I need? I need x-intercepts, okay? So let's do that. So to find the x-intercepts, one thing that I could do right here instead of having to use the quadratic formula is this is like our happy equation because it's already almost done, right? We know that when we're finding our x-intercepts, y goes to 0. So we know already that we have 0 equals 3 times x minus 1 quantity squared minus 8. Move the 8 over. So now I have 8 over 3 equals x minus 1 quantity squared, right? Square root both sides like this. I get x minus 1 equals plus or minus the square root of 8 over the square root of 3. And with that, what I would do is, first of all, I would most likely get rid of this root 3 by multiplying by root 3 over root 3. And so that's going to be x equals 1 plus or minus the square root of 24 over 3. I'm going to get 3 over 3 here, so I would say x equals 3 over 3 plus or minus the square root of 24 all over 3. And then I would break down square root of 24. Square root of 24 breaks down to the square root of 4 times the square root of 6. Square root of 4 is 2. So my final answer for my roots, this is in exact form, but not in decimal form, would be x equals 3 plus or minus 2 root 6 all over 3. And actually, I would need to find those answers, like the roots. I mean, yes, these are my x-intercepts, check. But I would need to use these intercepts. I'd like to have to use my calculator to find out exactly where they are. So I'm going to do that really quick. So I'm going to go 3 plus 2 root 6 equals, divide by 3 equals, so that's about 2.6. So one of my answers is about 2.6. The other answer, I would go 3 minus 2 root 6 equals, divided by 3 equals negative 0.63 and negative 0.63. So that's my negative 0.63 right here. And this value right here is my 2.6. Okay? Oh, I forgot. One other thing which I didn't mention, which yes, you do need to know, is your axis of symmetry, right? And that's going to be x equals 1, which is the value of your the x coordinate of your vertex. So this one is finding the discriminant, and what does it tell you? In order to do that, first, you see this 6, you need to set this equation equal to 0, priority. Negative 2x squared plus x, and I need to add 6 to both sides. So that's negative 3. So now I'm going to go b squared, b is 1. So 1 minus 4 times a times c. So that's going to be negative. So we have 4 times 2 is 8, 8 times 3 is 24. So 1 minus 24 is negative 23, which means that my graph is imaginary, and it means that I have 2 imaginary roots. And that's what it means, okay? For this problem, already set equal to 0, I'm going to go b squared, so that's 4, minus 4 times a times c. So that's what? 4 minus 24, again, negative, again, imaginary. So, let's make this a different problem. So let's make this actually a negative one, because I just want to talk to you about what that would mean. So 4 minus 24, so that would be 4 plus 24 if I changed it, right? And then that would be equal to 28, right? Okay, so basically what that means, right, if we change the problem to negative 1 and I got 28 as an answer, that would mean that I have 2 real and irrational roots, okay? That's what that would mean. And then likewise, if I had gotten, let's say, 16 as my discriminant, right? If I had gotten 16 as my discriminant, then I would have 2 real and rational, because you can take the square root of this. And if you can take the square root of your discriminant, right? The square root of your discriminant, in this case it was what, 16? If I can take the square root of my discriminant, it's rational. If I can't take the square root of my discriminant and have a whole number, then my answer is irrational, okay? And of course, anytime I get a negative, that's going to be imaginary. And the only one I really haven't talked about was this one, which is one real answer. And what that means is you're going to get like 36 minus 36, like that, and then you get 0. And if that's the case right there, you just have one real solution. And what that looks like is it looks like a parabola that's actually just touching in one place. That's what it looks like. A little bit of imaginary review. We're going to distribute this negative sign. So we have negative 1 minus 2i minus 4, move that distributive, right? And then minus I. So i's get combined. So we have negative 3i and we have negative 5. And then that's my solution. Or not my solution. I'm not solving anything. That's my answer to my expression. Simplifying only. This one right here, we're just adding. So 5 minus 9i plus 6 minus I. That's going to be 11 minus 10i. Done. This one right here. Now remember, we want to take out as many I to the 4s as we can, because we have I squared is equal to negative 1. We have I to the 4th is 1. So anything that is a multiple of 4 is going to be 1. So what we do now is I'm going to go, well, that's going to be I to the 32nd, because 4 goes into that, times I. So that's 1 times I, which is I. And then this one right here, I to the negative 35, oh boy, that one right there, that's actually 1 over I to the positive 35 power, which then means that I need to get 4 in there. So that's going to be 1 over I to the 32nd power times I to the 2nd power, so that's 4, times I. And so what that means is I've got 1 over, I to the 32nd is 1, times I squared, which is negative 1, times I. So 1 over I, and 1 over negative I, can't leave an I on the denominator. So we're going to make that times I over I. So what that now means is I get I over negative I squared. I squared is negative 1. So I've got I over the opposite of negative 1, which is positive 1. So my answer is I. Okay, that was tricky. For this one, we're going to do something like this, where we can't leave an I on the denominator, but we're only going to multiply by I over I. And so I times 3, so that's going to be 3i plus I squared over, and this is going to be negative 4i squared. Well, with this one, I squared again is negative 1. So what we have is 3i, and this is also negative 1, so minus 1 over this value. Now, what do we have? Negative 4 times negative 1, which is 4. So this is 4, and now I've gotten rid of the I on the denominator. So we're happy campers now. Okay, so for this one, we are actually going to multiply by, the conjugate of this denominator, all right? And by doing that, that is going to rid me of the I on the denominator, okay? So the conjugate is 1 minus 2i, 1 minus 2i. And so in distributing, I get 1 times 1, which is 1, 1 times negative 2, so that's negative 2i, 1 times negative 2i. I get negative I times 1, so that's negative I. And I get negative I times negative 2i, which is positive 2i squared. All over 1 times 1, which is 1, 1 times negative 2i, which is negative 2i, 2i times 1, which is 2i plus 2i, and then 2i times negative 2i, which is negative 4i squared. And so I need to move this because I'm running out of room. And so what's going to happen here is that the I squareds are actually going to become negative 1. So that's going to be a negative 1. That's going to be a negative 1. Okay, so on the numerator, I get negative 2. So 1 minus 2 is negative 1. And then I get negative 2i minus I, which is negative 3i. On the denominator, these two i's are going to cancel. 2i minus 2i is gone. This negative 4 times negative 1 becomes plus 4. 4 plus 1 is 5. Okay? And for these right here, these are, I think I did something like this up here, but I to the 34 is the same thing as I to the 32 times I squared. So let's think about that. I to the 32 is 1. Anything that 4 will go into is 1. So that's 1. I squared is negative 1. So 1 times negative 1 is negative 1. Okay? I to the negative 134, those are negative. I to the 32 is 1, so that's done. But let's look at I to the negative 34. That's going to be 1 over I to the positive 34, which is actually not as difficult as this one, which, I mean, not that it's difficult, it's just like multiple steps. This one is just going to be 1 over I to the 32nd power times I to the second. I to the 32nd is 1. I squared is negative 1. So we have 1 times negative 1, which is negative 1. So we have 1 over negative 1, which is negative 1. So that means that I to the negative 34th power is negative 1. I think for me, the takeaway from that is just make sure that if it's a negative power, it's got to go to the denominator, okay? This one right here is, this one says negative 3 plus 2i quantity squared. So for this, you know, you're going to multiply, you're going to like do 2 parentheses, or you're going to use a shortcut. Shortcut is square the first term, 9, square the last term, so that's going to be plus 4i squared. Multiply these 2 terms inside, so that's negative 6i, double it, negative 12i. And now just simplify. This I squared is negative 1, so this is going to be negative 4. So 9 minus 4 is 5, and then I've got minus 12i, and that's the answer to that right there. Where'd it go? Okay. Finding the zeros of the quadratic equation, again, you have to set it equal to 0. So this is just going to be 4x squared minus 7x minus 3 equals 0. I wonder if this factors. Let's see if it factors. Use the b squared. 7 squared. So the 49 minus 4ac. Let's see if this factors. 49, 16 times 3. That's 48, right? And so 48, if you add, because these are add, right? 9 and 8, 17, 8, 97. That is not a perfect square, so that means it's not going to factor. Okay, so that means that if it's not a perfect square, it's not going to factor. If it was a perfect square, it would factor. We're going to use the quadratic formula. X equals the opposite of b, plus or minus the square root of b squared. We just did this. 49 minus 4 times a times c. And this is all over 2a, okay? So we have x equals 7 plus or minus the square root of 16 times 3, 48 plus 49. Well, what did I say that was? 48 and 49, 7, yeah, 8, 97. So this is 97 all over 8. And so, you know, those are my zeros. And yes, I do expect you to know how to make that into a decimal equivalent. And the way you do that on your calculator is just to go 7 plus the square root of 97, go equals, and then divide by 8. That's going to be about, so x is about 2.1. And then the other one would be 7 minus the square root of 97 divided by 8, and that's negative 0.36, comma, negative 0.36. And so these are my 2 roots, or zeros, okay? For this problem here, I would first get rid of this 1/2 by multiplying by 2, and I'm going to have 2x minus 3 quantity squared equals 8. I am going to now square root both sides, And in doing that, I get 2x minus 3 equals plus or minus 2 root 2, right? And then move the 3 over, I get 2x equals plus or minus, whoops, I'm going to fix this. I'm going to actually put the 3 first. So 3, when I move this over, right, plus or minus 2 root 2. And my last step would be, for my roots, 3 plus or minus 2 root 2 all over 2. And the only other thing, yes, of course, I would expect that you would reduce that if you could. And when you can, I'm saying that's 3 over 2 plus or minus root 2. Like that, or make it into a, or make that into a decimal equivalent. Problem here, find the maximum value of the function. What I'm looking for is the highest point. So we would say g of x is equal to, I'm going to do this, negative 3x squared plus 12x. I want the maximum value, so I do want to find the vertex, of course. So I'm going to say, I'm going to use the vertex shortcut, and I'm going to see the vertex shortcut, which says negative b over 2a, and then plug that in. I mean, if it's easier or quicker for you to actually complete the square, I mean, go for it. I think that's easier too. The opposite of b, so negative 12 over, opposite of b over 2 times a is negative 3, and so that's 12 over 6, which is 2. So my x coordinate is 2, which means now I'm going to plug that back in, and I'm going to get negative 3 times 2 quantity squared plus 12 times 2. And that's 4 times, that is negative 12 plus 24. So that's 12. So my max value is at 2 comma 12. So 2 comma 12. Looks like I go through 0, 0. And so my graph would go up like this. Of course, my axis of symmetry would be x equals 2. They didn't ask that. They just asked for the max value. We do have a poll, so we're going to finish off with homework. And so I would expect that you are going to take your quiz at 4 o'clock on Friday. The Canvas portal will close at 2 o'clock. Complete the packet for the midterm that I have posted, and check your answers before turning in your midterm packet, which is worth 20 points. All right.